All right, let's get started. Welcome again, everyone, and thank you for joining us as we present our first webinar of 2021. My name is Lisa Shaw, and I'm on the marketing team at SICK, and SICK is a leading provider of sensor solutions. Today, Jim Gilbert, our market product manager for photoelectric sensors at SICK, and Jay Johnson, a market product manager for motion control sensors, we'll be talking about the latest web guidance solutions to provide your manufacturing processes. They'll be sharing how you can improve specific packaging and manufacturing processes with web guidance solutions and sharing success stories along the way. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the Q&A box in your control panel, which can be found on the right-hand side. We'll take some time at the end of today's presentation to address as many questions as time allows. Also, we will be having some poll questions throughout today's presentation, which also can be answered and found in the same location, which is on the right-hand side of your screen. A few other things I wanted to mention is that this will be recorded and a copy of this presentation will be emailed to you following today's presentation. And lastly, please place your WebEx in the side-by-side view. This allows you to view the content that our presenters are sharing, such as their PowerPoint slide, in addition to their camera. They'll be showing some live demos along the way. If you have any issues, please send a message to the host. Now, without further ado, we'll turn our time over to our presenters, Jim and Jay. Please take it away.
Great. Thanks a lot, Lisa. I'm Jim Gilbert, and with me is Jay Johnson. And today we'll be talking about web. Today we'll be talking about web control solutions from SICK. We're going to take a look at some of the market characteristics and trends. We're going to look at some specific applications, and then we're going to start getting into more specifics on products that can help you solve these problems. So, without further ado, these are the products that we'll be introducing at a later point today. So we're looking at fork sensors from the SICK portfolio. Also, SICK has a collection of solutions that can offer analog outputs, including an AS30 product and also an MLG web checker. We're not going to go into detail on the products now, but we will at a later time. And then Jay will be talking about a new innovative product called SpeedTech, which is a non-contact laser measurement sensor that can tell you the speed and length of an object without touching it. So this is pretty revolutionary. So looking at the web control process itself, we're really honing in on two different areas. It's either the production of the web itself, or it's, say, in primary packaging where an OEM or might be using the web to place product. Say it could be food stuff or any type of material inside of a package. So these applications for process and production could be in web forming, web alignment, web layering, to produce anything from paper products to actual packaging that keeps product protected and ends up on the shelf. Primary packaging side, it could be packaging forms, it could be bottling, and it could be closing of packages. So these are the primary areas that we'll be focusing on today. When looking at web forming itself, there's just such a wide variety of webs that exist out there. Could be anything from types of plastics of all different types of transmission levels between opaque and almost totally clear. It could be machine tool looking at metal sheets and steel. Could be fabrics, could be rubber, and then obviously paper is a huge portion of the industry. The main point here is that each web has its own characteristics. SICK delivers web control solutions to address all of these different type of web properties. Look at the other end, so one is web production, and at the other end, the users of the web. So this would be OEMs that produce equipment, and eventually this equipment is used. So in this case, we're looking at a vertical form fill seal. So the animation at the right is showing is into the process, the contents are loaded in the bag, and then the bag is sealed. So you can imagine all types of different food products. It could be It could be coffee or it could be pharmaceutical product. And it can even be hardware, in this case, looking at, say, screws or nuts. And think about the complexity of the packaging. Resealable packaging is really taking over, and also the idea of putting the product directly into a pouch or a bag rather than putting it into a box. There's characteristics such as labeling and marketing to these bags, and that's really how the company is promoting itself, directly in a bag. So, the point here is that the increasing complexity of packaging and recipe batching requires smart sensing, and smart sensing throughout the entire process itself. So in general, there's market demands that are driving this increase in automation. One is just automation itself, trying to reduce or reallocate labor that's applied to producing goods. When you are applying more robotic solutions into your process, you need to make sure that motion is coordinated better. It could be for a picking application or just simply for web guidance. And then looking at demographics, increasingly our population is aging, or we're valuing packages that can be resealed just for convenience. So that's a change in how people are spending their money. And then also on the demand side, there's flexible supply chains that need the flexibility of buying product where it makes sense to purchase it. So it could be overseas or it could be domestically in the US. And then, as I mentioned before, this trend of resealable packaging and then frequent recipe changes. You can imagine if you go to your local gas station and pick up a product, and then you go to a big box store, you can find that same package packed in individual pieces and then packaged in, like a 48-piece box that requires different levels of packaging. So on the production side, for production controls, we could simply look at, say, a go, no-go adjustment. And this might be a fork might provide adjustment. It would just simply tell you, is the web there or not in the right place? When you're looking at web measurement, this would be an analog output actually determining, if it's drifting, and then you could use motion controls to readjust the web to make sure it's properly aligned. And then finally, with web speed and length, here we're directly measuring product to eliminate possible roller slippage. Depending on the type of web, it might be difficult to actually measure the mechanism itself. And you may need to monitor directly on the web because there's mechanical slippage that occurs. You need to know exactly where the web is and what speed it's moving at. And then this also plays a factor with web tension control. So maintaining proper tension is critical to maintain a steady process. So the bottom line here again is that modern packaging requires precise web control and flexible equipment. So looking at some applications, up in the far left, we're looking at, say, as a roll comes off into a process. So here we have a fork sensor, and it's simply looking to make sure that the material is actually there and that it hasn't walked off too far to the left or right. In another example, we're looking at a film guide in the center picture on the top, and this would be a place where we might want to have an analog output. We have a product called AS30 that'll look at if a product is drifting to the left or right and actually give an analog feedback. This is an example that's a little different. It's looking at, say, an entire application, but you can see that this is really a different type of a web. It's gummy. You can think of foodstuffs or other materials that might be similar to this as well. But in this case, you may need to measure not only the whole width of the web, but you want to know, is it drifting one way or another? These types of webs can also be found to have multiple webs. So maybe there's 3, 4, or 5 webs all in the same location, and you need to keep track of all of them. Down in the lower left-hand corner, we're looking at packaging, say, in this case, it's a sandwich, so it needs to be sealed properly. There could be some marketing, could be some labeling material that's on there. Also, if it was resealable, it's important to get that sealing in the right position. That way you don't disturb the resealable portion of the bag. And I'll let Jay speak to the last 2 images on the lower row.
Thanks, Jim. So in the lower middle, cut to length. Obviously, when we have endless material, or I'll say a web, at some point we need to break that into individual pieces, whether that's in the packaging side or the converging side if we're joining multiple materials, whatnot. but in most cases that length is very critical. And as Jim mentioned on the previous slide, if we're relying on the, I'll call it transport mechanics, the rollers, pinch rollers, whatever even conveyors, whatever the case it may be, there's a chance that the material will not be uniformly moving with the mechanics in all times. There could be slippage. There could also be issues where you can't touch the material. Say in the tire build application in green rubber, maybe the material is too sticky to actually put a wheel on. And so in this case, we have a new, really innovative product, the SpeedTech, which we can measure the cut to length very accurate without contacting the material. So no contamination, no possible damage, and also important, no wear and tear on the sensor itself. Going to the lower corner, labeling. This could be a function of position or speed. So depending on the type of material, how fast it is, the accuracy required, we may be able to apply labels or even print labels just by handling a tight speed control. If not, again, we can precisely measure the length in addition to the speed with this non-contact SpeedTech. And we'll learn about that more in upcoming slides. Thanks, Jim.
Yeah, thanks a lot, Jay. So now we'll take a look a little closer into some specific products that we just touched on. So first, we'll look at a fork sensor. So this is a fork with a wide variety of shapes and sizes. This one is profile. It can fit into small spaces. There's a lot of different features about this type of product, so it can be used in a variety of applications. A big standout here is that it has IO link, and so this could be used in recipe changes, so maybe you have different types of materials coming through, maybe the position of the web changes, and you could reteach it on the fly. It could also be for different types of materials. Say you're looking at a clear material in one batch, and then maybe in another case, it's a different type of material, opaque. You could reteach it remotely and adjust to the change of behavior that's produced. You would use a product like this. It could be, again, in a vertical form, fill, and seal application. It could be applied at different points in the process, and its small size lends itself to fitting into tight spaces. Again, they're available in different sizes, so if you need more room for, say, web flutter, you could identify a fork of different size. There are other technologies. The one I mentioned before was photo or optical. There are also ultrasonics, and then even you could think about the same application could be solved in some cases with inductive, depending on the material properties. Forward looking at this product is called an AS30, and this is a product that produces a beam and can be positioned up to 100 millimeters away from the web. And this provides an analog output of what the web is within a certain range. So it's extremely accurate and provides really good control over where the web would be. Stand out here again is that it has IO link on board. So now you could recipe changes, you could blast in new parameters to the device as your webs are changing, as you're going through different recipe functions. So some common applications where you might find this type of product would be in consumer goods, looking at web guidance in a packaging machine. Same thing could be machine building. Again, maybe you're looking at the plastic film edge and sheet guidance. You could also see it in automotive applications, and the list goes on and on. But really, where you need a very precise analog output of where that edge is. You can also use this to measure the width of a web as well. So now we're going to move into, instead of just looking at the edge of the web, now if you want to look at the entire width of the web, this product is called an MLG Web Checker, and this is available to 3.1 feet, 5 meters wide. So you can see in the center picture, we could span the entire width of a web and provide very tight resolution as to how wide the web is. But if you'll notice in that picture in the center, in the bottom, it has multiple webs. So not only can we provide position and location of these webs, but we can also do it for multiple webs, which is really powerful. We can handle up to 5 webs. So this is a really powerful tool that can be used in a variety of applications. Again, it's flexible. It has built right on board, and then the accuracy that I mentioned before, up to 0.3 millimeters of accuracy when properly positioned. So it really is. Looking at how you position the web, this is different than your standard grid. So one thing is the geometry of positioning. So the web needs to be positioned 1/3 of the way from the receiver and 2/3 of the way from. So that's really critical to this process. So this is a different animal. It's not like a standard grid. What the sensor can do, and we'll be showing this later in a live video, can identify the first and last edge of a web. So at 5 webs, you'd actually have 10 different edges, and it can automatically find these. So this is a really powerful tool that can lend itself to a lot of things. Looking at the portfolio, as I mentioned before, this is a bit of a different animal. So SICK has a portfolio of light grid solutions for industrial applications. They come with different bus connections. You can look at Profi, EtherCAT, Ethernet IP, and CAN Open. We can do the same thing with the web checker, but the big difference here is its accuracy. We can provide up to 0.3 millimeters of accuracy, and these other devices, they can determine, say, the minimum detectable object is, say, down to 2.5 millimeters. However, those can be used at much wider widths, and they don't have to have that 1/3, 2/3 rule that I mentioned before. So just make sure you understand that the web checker is a different type of product. So next, we'll take a look at the linear motion portfolio, and I'll hand the ball over to Jay.
Okay, thanks, Jim. Before we get started here, I'll just add to the maybe one application example for all of those previous products that Jim spoke about, and that is typically on say an unwind or a rewind when doing some process in the middle of a web. It's quite important to keep that web straight, right? And usually the way that the control works is that we've got a wind side on the web that's in torque mode, a motor and drive in torque mode, and we're giving it a torque reference, and that's what's keeping the tension on the web. That can be pretty good on its own. However, if you have extensible material, in other words, material that could stretch a bit or something in the middle of the process that would disrupt that torque, we now can use those sensors that Jim just described in conjunction with your torque reference to the drive to keep that tracking straight. So in case that may be old news for several of you, if you're veterans in the web control industry, but if not, that's really the big benefit of adding that sensor to your machine. So moving on with the linear motion, we can detect speed and measure length of web with a variety of sensors, right? Typically encoders. Down in your lower left, encoders on, say, a standalone basis, maybe on the end of a roller or on the back of a motor that's driving the roller. When that's not good enough, or when we have a chance of slippage, as we talked about earlier, especially in really precise applications, we may need to add a wheeled encoder. And this is where the wheel rides directly on the web, and we eliminate that chance of any I'll say motion compliance due to mechanic attributes. However, in a lot of cases, that material can't be touched. We referred to rubber, maybe it's food, right? Maybe food products or medical products that can't be contaminated. So we directly cannot touch the material on the web. This is when the SPTech really shines, and we've got a really neat product and a great advantage, I think, in the other two technologies shown on this screen. It does come with a higher price, of course, but application dependent, it is a quick ROI, and we'll show you the benefits of the product now. So next slide, please, Jim. Okay, so here it is. This is a non-contact laser-based sensor with an encoder output. So interfacing to your equipment today, it requires basically a quadrature type encoder input or even just a high-speed counter input. So nothing new, nothing needs to change on the control side typically. It can measure very fast, up to 10 meters a second, and is compatible with really quite a variety of materials, including textured materials, smooth or shiny surfaces, dark surfaces. Very, very versatile as far as the material or the type of web that you may be transporting. Has a good typical industrial automation IP rating, so we'll put up with fairly harsh environments. Notice IP 65 on the body and 67 at the connectors. However, if you would need to go to even a more harsh rating, say an IP 69, this unit could be mounted inside of a box and the laser can shine through a certain glass type. So again, can be covered up in the event that the environment is rough. Highly repeatable, highly accurate. The unit comes in a couple of varieties today of resolution, either 4 micron or 100 micron. So depending on the accuracy that you need, we can get down to a very tight resolution, or if that's a little bit just too much noise, we can loosen it up to the, again, 100 micron resolution. There's a standoff distance from the material specified at 50 millimeters. It's very forgiving. Our specification says plus or minus 5 millimeters, so plus or minus 10%. Saying that, I would encourage even testing if there's a chance that the web might move or might drift a bit on I'll say a vertical level, because typically being closer to the sensor is not bad. Being further than that 55 millimeters, that can cause some inaccuracies. But again, really encourage testing if you do think that's an issue with your application. Probably the biggest unique feature of this is compared to some other sensors on the market is that this is a class 1 laser. So there are other sensors on the market that will measure speed of web laser based, but typically class 3. With a class 1, this is a much lower cost device in both the device itself and in the operational attributes, because with class 3, there are many safety requirements, need shrouding, guarding. The people working around the application need to cover their eyes, need to have glasses. And with class 1, it is no issue with safety. So Lisa just put up a poll question I'd like to direct everyone to. Please take a look at those questions as we continue and answer those to the best that meets your experience. Go ahead, Jim. Next slide, please. Real quick, I won't go over the specs detail by detail, but typically you power it up with 24 volts. It can be ordered with either a TTL, so in other words, 5-volt output, or HTL, which is going to follow the power supply source. So if you powered it with 24 volts, you would get a 24-volt pulse out. And again, we've got A, B, and complement channels. So just like a regular quadrature encoder. And what's that mean? A and B means that we can detect both directions. It's very fast, powers up quickly, standard M12 connector. It's a nice package, nice aluminum housing, and again, set up to meet most industrial style applications. Go ahead, Jim. And a bit about the way that it works. There are 2 laser transmitters and 2 receivers in the unit. It sends out a laser beam at a wavelength and then looks for the reflection from the material and looks at the frequency of that reflection. We then compare the transmitted frequency versus the received frequency, do some averaging between the 2 beams, and this is how we get a very precise, very accurate speed measurement that can also be used for length measurement. So again, like any typical incremental encoder, we know the resolution. In this case, will be either 4 micron or 100 micron. And so for every pulse coming in, we know that we traveled that distance. And so again, the product can be used to measure and control speed or cut to length applications. I'll point one thing on the limitations of the product. We do need some actual frequency difference in these signals to record a speed or to understand what the speed is. That means we have to be moving at a certain rate. So you can see in the bottom note, we specify that down to 0.1 meters a second, which would be fairly slow on any web speed and actually most material moving. But anything below that, we really can't guarantee the accuracy. What I can say is that the repeatability is quite good. So even if you happen to have an acceleration and a deceleration ramp that were long and might be down below this 0.1, the sensor is typically going to be repeatable. And so with that, that can usually be handled as far as an offset in a control system. Other than that, the only material that is really very questionable at all is sometimes very clear, say a clear cellophane film, clear plastic film. And that even works in many cases. So again, if you're dealing with something other than clear plastic, we're pretty good to go. If you are looking at clear film, clear plastic, we really encourage you, let's get one in your hands and test it. Okay, next slide, Jim. And the size, it's fairly small. It's about the size of a new cell phone. So you can see 95 by 140 millimeters and 32 and a half, about a inch and a quarter, inch and a half deep. So easily mountable, really sets up easy. I'll point out that the little, I'll say red diagram toward the bottom of the screen, that shows the landing surface that you need. So typically 2 by 3 millimeters is nominal. Therefore, this product really will measure small, say surfaces such as cable as well. So small extruded tubing, things like this. So web is a great application, but also think of this product for any other materials that may be moving. And next slide, Jim. Just a little bit about applications. We've talked about this, but again, think of speed and length. Anywhere that you need to control speed, you need to coordinate maybe multiple webs coming together to be, say, laminated or colandering in tires, food packaging with material maybe coming into a wrapper, and then cut to length. And again, we've got down to 0.4 micron, or excuse me, 4 micron resolution or 100 micron resolution. And next slide, Jim. And I'll turn it back over to you. Thanks.
Great. Thanks, Jay. So that's a quick overview of the different types of technologies that SICK offers. It certainly is not comprehensive, but it hopefully can give you an understanding of some different solutions that we have. So in each case, whether you're looking at web presence, web measurement, measuring the entire web, or you want to know speed and length measurement, we have different solutions for these. And in each case, there's reasons why you choose SICK. For web presence, we offer IO Link, price and availability of the product in addition to its size. And as far as measurement, you're looking at incredible accuracy that we can deliver from both the AS30 product and the Web Checker product. And then, as Jay just went over, the Speed Tech is really an innovative solution where you cannot touch the product and you wanted to know both the speed and, say, the length of a web. So these are really powerful tools. So next, we're going to go into a live video where both Jay and I will be showing some of the products. If you wanted to find these products on the web, we've provided the QR codes here. So you can just use your phone and scan these, and it'll bring you right to the product that you're interested in. So thank you for your time, and I'll be cutting over my camera to a different. As I do this, I'm going to ask that Lisa presents a different poll. This would be taking a look at the number of webs that you use. So I'll see if I can't get my video to come up the way I want it to. Bear with me as I'm locating my video.
Thank you, Jim. And yes, the poll is just activated. You have about a minute or two to respond.
All right. You should now be seeing a different view instead of me. You should be seeing my product. And then also I'm going to show you the software that connects to it. This is SICK software we call Sopus. And this is a live view. So in my camera, again, as Lisa mentioned at the start of the presentation, if you orientate the screen so you can see half the screen is my video of the camera, and the other half is the software, which we call Sopus, you'll be able to see how the two coordinate together. So I'm using a plate that I'm representing two webs with this plate. And you can see I'm getting a very nice clean representation, both of the width of the webs, and also I can find the center of the webs. So I can do this for up to five webs. And so if I say bring my fingers, or in this case, I'm going to bring a pen, or it's at the same distance, 1/3, 2/3. Here I've just inserted a new web into it, and it's automatically tracking it. So whether I go on the outside or go in between, you can see that I can track it. And if I set it up properly, it would be able to identify both the width and the center of that web itself. So it's a really powerful tool for automatically identifying your webs. If you did want to choose, say, a clear material, you could choose different types of, we call it fine or middle or coarse mode. This determines the sensitivity of the sensors, and that could be used for applications such as on clear material. The process for the sensor is basically you set it up, you can align it. Next step is that you would teach it without the material in place. And so I would remove the web material. If you can't remove it, you would simply pull it side to side. At some point, all the beams need to see each other when you're doing the sensor teach-in. And then finally, the last portion here is a material teach-in. And so this is a really powerful portion of it. We're actually teaching to the web that you have. So I'm going to press this button, and it will identify my webs automatically. It gives you a quality of run, basically. And so now here we have an output that shows the width of these webs. And this information can be streamed directly into the PLC by these field registers. Once those are mapped in, you have your process really, you can really control your process well. So that's a quick overview about the MLG Web Checker. It's a really powerful tool. So reach out to your local SICK resource, and you can work on applications of your own. So I will stop my camera, and I'm going to hand it over to Jay.
All right. Thanks, Jim. I will change my view, change cameras. Okay. Let me unplug my counter and turn it on, and I'll explain a little bit about what we have here. So we have the SPTAC mounted over the top of it's a whiskey barrel that's on a Lazy Susan bearing. And so you can imagine the surface of this barrel is rough, and it's not smooth. It has a lot of warping to it. I don't know if you can see that in the camera, and a lot of variation in color, including some stampings. There's a red stamping here. I've got some black dirt marks in the wood grain itself, and then it's varnished with some reflection. So kind of a rough surface. I have the SPTAC connected with a single cable with M12 connectors to a digital counter. And I'm also powering the SPTAC through a battery that's in this box. I'll go ahead and reset. And so with the counter, we're actually just measuring pulses or measuring clicks. So as I rotate, you can see the counter climbing, and I'll go reverse direction. So again, we've got an AB quadrature style signal, and we can detect direction. And again, if I can move very slow, I can move very, very fast. We're good for material up to about 10 meters a second. We're also good, we'll hope my counter stays in place, and I'll introduce some various patterns and colors. And we'll overlap them a little bit, maybe make some longer, some shorter than others. And if we keep an eye on our counter, we're still going to read, right? So again, any type of material that you really have, other than clear, we would like to do some testing on, but because it does work in cases, in other cases it may cause issues, so well worth the test. Another thing I'd like to bring up is that I can introduce a high amount of light. I can strobe it. Really isn't going to cause any effect. So, very versatile product. We've had great success with it. It's been launched and available now for about a month and a half. And we've seen it used on many applications. Prior to that, we did very extensive testing on a global basis with a variety of not only web applications, but many other material processing applications. And it's proven to perform very well. SICK has been developing this product for quite some time. So we encourage you to get out there, give it a try. You can reach out to your local sales manager or applications engineer. We have demo units of it, and we'd be glad to get it in your hands and show it to you.
Great.
Back to you.
Thanks a lot, Jay.
Yeah,
great. Thanks a lot, everyone. I appreciate it. Lisa, I don't know if we have any questions, but I appreciate the time.
Yeah, thank you, Jim and Jay. Looks like we do have some time for questions. So for our attendees, if you have any, please type them into the Q&A box in your control panel, which is on the right-hand side of your screen. And while I'm collecting those questions, I'm going to activate one last poll for you. And the question is what type of web material do you produce or use in your production? So I will open up that poll. And the first question, Jim and Jay, that I received is, can your web checker detect on clear webs, like on the labeling of a clear water bottle?
A clear water bottle, I think that might be pushing the limit. Typically, we recommend that the transmission of the material would not be more than, say, 20% transmission. So that would be more like the clarity of, say, like a clear beer bottle or soda bottle. When you get down to something as clear as the wrapper that goes around a foil like that, our standard offering of light grids could easily do that, except they wouldn't provide the same level of resolution. So I'm going to say maybe, but you definitely want to test it out. And that fine mode that I mentioned is probably what you need to do. But you could reach out to us and we could try a sample of the product. That's something I would want to verify before we move forward on that.
Great. And can the SpeedTech series be used on a moving pipe? And what are the temperature limits?
SpeedTech can be used on a pipe. We recommend typically we would like to see a 10 millimeter diameter or larger. And so yes, that is somewhat of a common application. I will say, depending on the point you brought up, as good as temperature. The SpeedTech, of course, has that 50 millimeter standoff. And so if the ambient of the pipe is going to heat the SpeedTech up beyond its specification, then there may be some issues. We've seen people use air knives, other means of keeping the sensor cool. I will say that, say, in a a steel mill, rolling steel or something. No, it's too warm for that because we are going to be too close.
Great. The next question is there a minimum material speed for speed tech?
Yep. We talked about that a bit in the mid of the slide deck or so. We specify a 0.1 meter per second. So that is our official cutoff. Just want to clarify that below that, we typically still get a repeatable number. It's just that below that, it's not accurate. And so if we can deal with that, in other words, with an offset or whatnot in the control, if you have a long acceleration ramp or a long deceleration ramp, but that ramp is consistent, that's typically not a problem. If the material itself is always going to be moving at below the 0.1 meter a second, then I would say no, that's probably not an application for speed tech. Then we probably want to look at something more as a contact style or an encoder on the transport mechanics.
Sounds good. This question comes from Christian, and he says, we have a web that ranges from 3 millimeters to 15 thick. Can the speed tech handle the variation?
I would tend to think that one would be okay. What we've seen is that further away than the specified 55 millimeters, remember nominal is 50 with a plus and minus 10, further away can cause some issues. Closer, it can depend on the material and the lighting or the reflection properties of the material. But typically, if we set it up so that it was at 50 with your thinner web, your smaller web, and then as the web grew, it became closer to the speed tech, I think that's probably a good application. So I would definitely look at testing that.
Thanks, Jay.
Yeah,
those are all the questions I see. So Jim and Jay, do you have anything else you want to add before we wrap this up?
On SpeedTech side, I would just add that again, it's a pretty disruptive product in a couple of ways. Again, class 1 laser versus class 3. There are a couple of other class 1 products out there. However, their price point is much, much higher than SpeedTech. So again, I think we've got a really disruptive, great performing product at what I think is the best price in the industry for this kind of technology. So I encourage you to take a look at it. Reach out to your SICK salesperson or applications engineer with a technical question. But other than that, I really appreciate everyone's time and attendance.
Yeah, thanks again.
Thank you.
Yeah, thanks again, Jay and Jim. And to our attendees, for upcoming webinars, you can see our list on our website. And also we send out a newsletter that shares our upcoming events. Have a great day. Thanks again.
Thank you.
Thank you.